So now we're going to talk about is the rules for adding and subtracting. And what we're after here is how many significant figures should our answers have when we add numbers. So the rule for that is as follows. The answer must have the same amount of decimal places as the operand with the least amount of decimal places. So what does that mean? Well, what we're after here is the fewest amount of decimal places. So if we were to add these two numbers together, our answer should have the number with the fewest amount of decimal places. So let's start by doing this. First, we'll add these two, punch that into our calculator. And when we do that, we get 5.351. All right, 5.351. Now, this number is not written to the correct amount of significant figures because what we're after is the least amount of decimal places. So here's one operand here, and here's another operand here. Now, out of these two, which one has the fewest amount of decimal places? Well, it's this one right here. So that means that our answer should have two decimal places because this number has two decimal places, 1, 2, whereas this one has 3. So that means we're going to write this number to two decimal places. So we're going to drop this 1 here. So we're going to write 5.35. Right? And that is the correct answer to the right amount of decimal places, to the right amount of significant figures. How about this one here? Okay, so 214 plus 7.88. We punch that into our calculators, we get 221.88. Right? 221.88. Now, which operand here has the fewest amount of decimal places? Well, this operand has 2. 7.88 has 2 decimal places, whereas this one here has only 1 decimal place. So our answer should have only 1 decimal place. So that means we're going to drop this 8 and round this to 9. So our answer should be 221.9. Okay. How about down here? Another one. So 14.999 plus 3.0. Okay, so here this one has 3 decimal places, and this operand, okay, 3.0 has only 1 decimal place, so that means our answer should only have 1 decimal place. So our answer would be 17.999, but to the right amount of decimal places, we're going to write this to just 1 decimal place. So that means our answer will be 18.0. We would have to round up. How about this one right here? So we're doing a subtraction. Okay, punch this into our calculator. We get 5.6243. And this is not to the right amount of decimal places. Okay, the fewest amount of decimal places here is 3. Okay, so we're going to write this number to 3 decimal places. So we're going to write 5.624. We're going to drop the 3. All right. So, all right. How about this number? Okay, so we got 2.11 minus 18. Okay. So in this case, what we would do is, again, the same process. So when we put that into our calculators, you get a negative number. So you get minus 15.89. All right, but the fewest amount of decimal places here is 1. So that means we're going to write this answer to 1 decimal place. So we're going to write negative 15. We're going to drop this 9, and since it's a 9, we have to round this up. So 15.9. Okay, and that is the answer to the correct amount of significant figures. And then this question here, sort of the same thing. Okay, the answer is still going to be 15.89, but to the correct amount of significant figures, the 18 here doesn't have any decimal places, which means we're going to have to write our answers to no decimal places at all. So in that case, how are we going to write this number? How are we going to round it up or round it down? Well, if you said 16, if you're going to have to round up to 16, you are correct. Okay, so it's going to be negative 16. All right, and that's how you would write this number to the, these are the rules for addition and subtraction. The same thing also goes to for if you had more than two operands. So for example, if I write 2.0 plus 3.00 plus 4.1. Okay, so which one of these operands has the fewest amount of decimal places? Well, the 2.0 only has one decimal place, the 3.00 has two decimal places, and the 4.1 has one decimal place. So that means we're going to write our answer to just one decimal place. Okay, so our answer would be, this is without decimal places yet, or sorry, without significant figures yet, it would just be 9.10. But again, we're going to write that to the correct amount of significant figures. So what we're going to do is we're going to drop this 0 and it will just be 9.1 because it's only supposed to have one significant figure. Okay, so this answer would technically be wrong if you're writing it to significant figures, if that makes sense. And it would be the same thing if you wrote a number with 4 operands, or if you wrote a number with 5 operands, you would just take the number with the fewest amount of decimal places. So in the last bit of this video, we're going to talk about the rules for multiplication and division in terms of how many significant figures are there when you multiply and divide. So the rule for multiplying two numbers or more than two numbers or dividing is as follows. So the answer must have the same amount of digits as the operand with the least amount of digits. So if we go back to addition and subtraction, we were counting decimal places. With multiplication and division, we're not counting decimal places, we're counting the entire number, we're counting all the digits. Okay, so here, when we multiply these two numbers, 2.0 times 3.11, we get 6.22. But that is not the right amount of significant figures because we want it to match, okay, you want this answer to match the operand with the fewest amount of digits. So here, this number here has 3 digits, 1, 2, 3, okay? And this one has 2 digits, 1, 2. So that means our answer should have 2 digits. So 6.2. We drop this 2. If we go down here, okay, 9.1 divided by 3.221 will give us a really long number. So we'd get 2.825209562. So as you can see, this can be a little bit problematic, especially if you're trying to be efficient and fit a lot of stuff onto a page, or if your test says to write to the right amount of significant figures. All these digits are not significant with respect to the answer here. So what we would do is we would match this answer to the amount of to the operand with the fewest amount of digits. So again, we're not counting decimal places like we did in addition and subtraction. We are counting digits. We're counting the entire number. So this number here, 1, 2, has 2 digits, and this number here, 1, 2, 3, 4, has 4 digits. So 2 is less than 4, therefore our answer should have 2 significant digits. So we would drop all this stuff right here and just write 2.8. Okay, now if we came down here, okay, and we wrote, and we did this division, again we would get a really long number. So we get 3.056666666, and it'll go on and on and on and on. 6, 6, and we'll end it right here, 7. Okay. Now obviously you're not going to be able to write an infinite number of 6's on your page, but instead you can use significant figures. So since this 3 right here is the operand with the fewest amount of digits, there's only 1 digit here, whereas this one has 3 digits. Your answer should only have 3 digits. So that means our answer will just be 3. Okay, so we'll drop all this, okay, and our answer will be 3. Alright, how about this number here? So 14.2 times 30, the answer will be 426. Okay, now which number here has the fewest amount of digits? Well, it is 30. And because it only has 2 digits, and the 14.2 has 3 digits. And our answer here is 426. So now we ask ourselves, how do we write this number to 2 digits? How do we write this to 2 significant digits, right? Because it's 426, we can't just drop the 6. Well, actually we can. We can drop the 6 using scientific notation as we talked about earlier. So what we would do is, we would write 4.3, okay, we drop the 6 and then round the 2, times 10 to the something. So the decimal will start here, and then we'll just count to the end, 1, 2. So it'll be times 10 to the 2. Okay, you see how that works there? So we would have to write this number to 2 significant digits, which sounds a little bit counterintuitive, but it's okay because we now know how to use scientific notation, so we can write it in scientific notation and express our number that way. Okay, so here's another example where we end up having to use scientific notation. So 3,477 divided by 2.1. Well, that answer is a pretty long number, so we get 1,655.71428.6. Okay, and as you can see, that's a very long number. So how do we write this number to 2 significant digits? Because as you can see here, this has 4 digits, this has 2 digits, and we need to write this whole thing to 2 digits, 2 significant digits. Well, the way we do that, again, is by using scientific notation. So how would we write this number? The process is exactly the same. So we would start with, we just write the first 2 digits with a decimal in between them. Okay, so 1.7. Okay, and the reason why we're making it 7 is because the next number is a 5, so that means we would round this 6 up, times 10 to the something. Okay, and what are we going to be, what's it going to be? So I'm going to start right here, and then we're just going to count decimal places over to the decimal. So 1, 2, 3. So that means our answer is going to be 1.7 times 10 to the 3. Like so. Okay. Here's another one. This is a pretty good one too. So 2.11 divided by 3,477. So it's kind of like this question here, but backwards. So we would get this number 0.0006 6, 0, 6, 8, 4, 4. Okay, so obviously, as you can see here, this number is not written to the correct amount of significant digits or significant figures or sig figs. So how many significant figures should this answer have? And if you said 3, you are correct. Okay, this answer should have 3 significant figures. So the way we would write this is we would start at the first non-zero and put a decimal after it. Okay, and then we would do the first 3 digits after that. So it's going to be 6.07. Okay, this isn't going to be a 6, it's going to be a 7 because we're going to drop all this, which means we're going to have to round this to a 7 because an 8 comes after the 6. Times 10 to the something. So what's it going to be? Well, we're going to start here, and then all we're going to do is we're going to count backwards. Okay, so we're going to go 6.0684, or sorry, 6.07, my bad, times 10 to the negative 1, 2, 3, 4, times 10 to the negative 4. So as you can see here, it's going to be 10 to the negative something because we are counting backwards. Okay, so if we're counting backwards, it's going to be times 10 to the negative something. If we're counting forwards, it's going to be times 10 to the positive something. And in this answer, we can also do this with more than 2 operands too. So here we have 3 operands. We have 1, 2, and 3. Now, of course, the answer would be, we'd have to write our answer to 2 significant digits because the operand with the fewest amount of digits right here is the 2, and it only has 2 digits, whereas the 1 has 3 digits and the 3 has 4 digits. This one has the fewest, so 1 times 2 times 3, we'll just write it as 6.0. Okay. So if you're doing something like a physics question and your teacher says, okay, write this to the correct amount of significant figures. So for example, you could be given a question like this. You'll be given a distance and you're supposed to find the speed. So we'll say there is a track athlete doing a 100-meter dash, and he completes the dash in 5.2 seconds. Okay, pretty fast. How fast is the runner running if he runs 100 meters in 5.2 seconds? Well, the person's speed is going to be the distance, okay, delta d, divided by delta t, okay, so distance divided by time, which is going to be 100 meters divided by 5.2 seconds. And our answer will be, put that into our calculator, you're going to get a really long number. You're going to get 19.20, or excuse me, 230, my bad. 230,76923 meters per second. Okay, so obviously we're going to have to write this to a certain amount of significant figures. Okay, so what we can do is we can write, since we want to write to 2 significant figures, we will just need the first 2 digits. All right, so that means we would just drop all this, and our answer becomes 19, like so, 19 meters per second. keep in mind too, this number can also be written as this. Okay, 1.9 times 10 to the 1 meters per second. That is the exact same thing, because again, what you're doing is you're writing a 1, putting the decimal and then the 9, and then you would just move the decimal over 1. That's why you get the 1 here. That's how many decimal places you're counting. So we put a 1 here and you count over, and that's another way to write it. Similarly, these two numbers here, 2.8 for example, can also be written as 2.8 times 10 to the 0, okay? Because you're not actually moving the decimal places at all, you're just leaving it where it is. So you'd write 0 as the exponent. Same thing here, 3 can also be written as 3 times 10 to the 0. But that's a little bit redundant, so you'd almost never write a number in this form, just because it doesn't actually make it easier. But if you ever do see this, it means the exact same thing. So the times 10 to the 0 is a little bit redundant, because 10 to the 0 equals 1, essentially. So yeah, and that's it. And it's the same thing here too. This, writing it in this form would be a little bit redundant, just because, again, it's times 10 to the 1, and writing it as 19 would be the exact same thing. Alrighty, so that is multiplication and division. That is significant figures and scientific notation. Thanks for watching, and we'll see you next time.